Hi, my name is Bologna from TEKO Broadcast, and I want to present you our 15 kilowatt transmitter. It works between 40 and 15 kilowatt, and it is not a transmitter, it's an RF amplifier in this case. It can work as an FM transmitter, IBOC transmitter, or as in this case it works as an RF amplifier for a cyclotron application, and it is used in nuclear medicines, and we produce many amplifiers for science applications even. These characteristics that is needed for this application is the amplifier must be linear and must be perfectly linear, because one is driving the cyclotron, the speed of the molecules are depends exactly on the power that they are delivering to the cyclotron. So the power must be adjusted in a very linear way. Other characteristics of this amplifier is that it is liquid cooled. This is for many reasons. One of them is because with so high power it's very difficult to handle air. If it is needed to cold, normal air is a lot of air quantity and is continuously passing inside the amplifier to cool, and it creates logistics problems. In this case, it's cooled by liquid, so the machine can cool refresh the water. It's outside, it's not in the same room of the amplifier. Moreover, in this case, that is working in medicine application, we need to have an environment very, very clean. It's not possible to pass so high quantity of air inside. So, I want to show you these are how it's built. This amplifier is built by two amplifiers of 25 kilowatt each. We are now combining this coupler. You can see that in the top of the coupler we are taking the measurement of the real power, calibrated power, and we will read in this computer. Moreover, we can see what is the power reading by the logic. In this case, we are connected by Ethernet, by web. This is the web page of the transmitter. We will see the power here. The transmitter, as you can see, is going to this dummy load. This 18 kilowatt dummy load, and you can see it even of the connectors, 6-inch connector. The way I can see how the transmitter is put in the back side, we see each amplifier has an input water and output water. These are all the water arriving to each amplifier. Moreover, we have the two collectors, the main falls, where the water is passing through to feed each amplifier. Here we are. We have it's called a circulator. In this case, it's a special synthetic circulator developed by us, because this amplifier must work at any level of ROS, of USBR. In cyclotron application, the cyclotron can produce a huge quantities of ROS and USWR, so the transmitter can go in protection. So one of the special things of this amplifier is that it can work at full power at any level of USWR. Just because the characteristic of the cyclotron in this case is that it's a cavity with a high Q, so any small movement of the cavity by temperature or whatever circumstances. Moreover, it has a lot of sparks inside for the high voltage inside the cavity, and so it produces many times a lot of ROS or VSDR. For that, it's not possible to protect like in broadcast. Like we do in broadcast, then we have protections that works in case of high VSWR, because it's impossible to interrupt the function of the cyclotron in this moment. So it must work. In any case, we can apply a protection, we can stop, so it must continue to work. For this reason, we use this special project inside just to have this high resistance to work with high ROS. Moreover, we developed this special synthetic circulator to protect the MOSFET against the VSWR. Now we will show you the modulation capabilities, and I will show you with this generator how we can drive the amplifier linearly, modifying linearly the power, modifying the input power, and moreover I will show you how it works in AM modulation, FM modulation, or both, like in the case of the IBOC or the DRM application. So next step, we will show just the amplifier delivering the maximum power, and even in case of the several kind of modulation. Now I will show you how the transmitter works in a linear way. This is the web page of the amplifier, and in this case we are looking at the several menus. This is the total output power, and you can see we have approximately the same value of the two output power. This is the value measured from the direct coupler. Moreover, we can have here the measurements of each RF module, so we can see in one page the total amplifier. Here I will show you how increasing slowly the input power in a linear way, we see how the output power of the amplifier is increasing slowly, following the input power in linear way. You can see we are reaching now the 36 kilowatt, the 40 kilowatt, and so on. And you will see that we are working now not at maximum voltage of the power supply of the amplifier, because this works in the linear way. It depends the maximum power on the voltage of the. Now I
increasing the maximum voltage to reach a higher output power. As you can see now, we are reaching 45 kilowatts, just increasing the voltage output of the power supply, internal power supply of each RF amplifier. Now I will decrease. You can see, as in this case, even working on the power supply, we can control the output power. This is done to optimize even the efficiency at what the transmitter works. So we keep it in a linear operation, but at maximum efficiency. You can see the efficiency here. We are at 88% now. Well, this is output coupler measurements from the output coupler. Now what we will do is decrease the output power, and always decreasing the input level of the RF power, just to get approximately 20 kilowatt in the output, so we will be able to modulate the signals in AM. Here is the demodulator. We see we are working at 85 megahertz, and this is the spectrum analyzer. Because this is a special application, is not in FM band. It is so in this case is 85 megahertz. We produce the amplifier EV as 60 megahertz, 67, 130 megahertz. Now is working at 85 megahertz. So next step, I will show you how I will introduce an AM modulation. You can see now we have 0% and we have not demodulated output. Now I will enable the audio generator on the signal generator, and I will enable an AM modulation. So I will give off to this internal oscillator, to the internal oscillator, and you see we are working now at 400 Hz with 40% modulation. This is exactly what we are getting in our demodulator. 40% modulation with 400 megahertz. Now, if I change any parameter, you see here the sine wave demodulated. In this case, pay attention, we are AM modulation in this case. I will show you how I will change now some parameters on the modulation. And so you will see it directly in the oscilloscope and in the demodulator. We always keep the approach 40% modulation with 1 kilohertz, and we are now speaking about always AM modulation. Take a look. I choose now 15 kilohertz AM modulation, and we see how it is now producing 15 kilohertz in the demodulator. Now I will do something more. I will add an FM modulation. So we will see how the amplifier is able to keep both of them, like in the case of the DRM of IBOC. So I will go to FM, and I will add an oscillator to FM, deviating 75 kilohertz, and I will put this internal generator at 1 kilohertz signal. And I see in the spectrum analyzer how the signal is FM and is modulated in the oscilloscope with 1 kilohertz. So I will pass on to the FM demodulator, and we see we are deviating 75 kilohertz with 1 kilohertz modulation. That is exactly what I'm giving with my generator. Now we will again try to change the frequency, and so we see we are modulating in FM with 15 kilohertz, and again 75 kilohertz deviation and 15 kilohertz frequency. Okay, this is a 15 kilohertz frequency demodulator signal that I'm producing with my generator. But pay attention, because now we are still working with AM modulation at 40%, and we are still demodulating. In this case, of course, we have 15 kilohertz. I can change my oscillator to generate other AM modulation frequency like 1 kilohertz and so on. So what we show you in this video is how the transmitter can be modulated with a signal overpose that is one over the other. We have one FM signal, and over the FM signal we have an AM modulated phase. It can be phase or AM modulated over the FM signal. That is exactly what happened with the IBOC or DRM applications. Please excuse me, because I was needed to record again this part of video because the sound was not good. Last thing, take account, this amplifier is for a science application and is not optimized for FM and DRM application. Is totally different kind of work. But it's just to show you that these amplifier capables are to amplify linearly any kind of application. Thanks.